Now that we know how the Web2 architecture is built and how clients communicate with the servers, so how the browsers, our computers, communicate with the devices in the background or the computer programs in the background, let's now have a look at the Web3 architecture. And to do that, we will use the example of a decentralized app that you probably already know, which is OpenSea, the marketplace for NFT management. Okay, so we are currently on the OpenSea.io website. And at the first glance, you probably can notice that it's quite similar to the Airbnb website we've seen before, because we have some links here. The website reacts to my mouse. We can have a look at the different images, play with tabs to display different information as well. And if I will open the inspector, so again, right click and inspect, it will open the developers tool panel below. And I will go to the network tab. So as you can see, it looks the same. If I refresh the website, what you can see here below are all the different requests happening and requesting information that should be displayed on the website. However, what is the difference? Actually, on this website, what I can do is to connect to the underlying blockchain. And what I will do now is that I will try to log in with my Web3 account. Let me first clean up the network tab so everything here is empty. And I will click on Profile so that then OpenSea suggests to connect with a wallet. And I will choose MetaMask as this is the wallet I use and I have it as an extension here in my browser. So let's click on that. And please make sure to have a look at the bottom panel of the network. Going into MetaMask, the extension pops up. And as you can see here in our network, at the very bottom, I have 3 different requests. And if I will hover on it, so just have my cursor, my mouse on top of it, you can see that this request went to google.com and a very long address following that. Which basically means that we just opened the extension, which is part of the Google Chrome product. And these 3 requests are the last ones that have happened while I'm now interacting with the website. Going back to the extension, let me open it up again. And what you can see that MetaMask is asking me to choose an account that I want to connect with. I can click on next, and now I can see what will actually happen. So OpenSea will be able to see my address, account balance, activity, and suggest transactions to approve. If you don't understand exactly what does it mean, then don't worry, we'll speak about it in the future videos. So what I will do, I will connect. And note, please, what is happening now here below in the network tab. I will go back to the website. And if I will scroll down, as you can see, there is only one request that happened. If I will click on it, you can see that it's actually my Surge NFT passport, an image that I own. And there wasn't actually anything else happening here, although we performed the entire authentication process. So I proved my identity by using the Web3 wallet to OpenSea so that then I can log into my profile. Well, let's actually have a look what happened and how I was able to speak to the underlying blockchain. When talking about Web2, we mentioned the client-server architecture. But in order to understand what is happening behind the scenes of Web3, I would like to ask you to think about a house. A house which has different layers. And each layer is responsible for a different functionality. What we saw was the decentralized app, OpenSea, which was actually located in the rooftop layer, which is also called layer 3, the application layer. And this is the layer that allows you to interact with the deeper layers of the blockchain. And what you can find inside are dApps, so the decentralized applications. Some examples for then we have OpenSea, Uniswap exchange, MetaMask wallet, or CryptoKitties, the decentralized game. below that, what we have is layer 2, which is the scalability layer. Its main goal is to optimize whatever the underlying blockchain is doing, and it includes things like optimistic rollups or ZK proofs, which are the zero knowledge proofs. If you don't know what they are, don't worry, we will cover that later on. Some examples of the layer 2 solutions are Starknet, Optimism, or Polygon. And then finally, we go down to the foundation of our house. Without that foundation, we cannot actually build the house at all. And this is layer 1, the platform layer, the place where blockchains live and also smart contracts are stored. Again, as for smart contracts, we will speak about them later on. They will have an entire module and we will fully understand what they are and how they are built. In terms of examples, we already spoke about Solana. There is also Cardano or Ethereum. To give you a better understanding of what is going on behind the scenes, when we speak about layer 3, we mean here the front end. And this is what you see and what you can interact with. Layer 2, the scalability layer, focuses on efficiency. And what it does is that it takes the transactions off chain, so from the main blockchain, and it's processing them in batches, kind of on the side, to optimize the process, make it faster, and make it cheaper. We will mention a bit more details in the future videos here. Then finally, layer 1, the storage, where the data lives, which anyone can access through platforms like Etherscan, and also the platform, the layer which is managed by a network of thousands of peers. Speaking about peers though, if you remember, we were talking about nodes at the very beginning of the course. We talked about nodes, we talked about the consensus mechanisms. But actually, we cannot really see it here in our house with 3 layers. And the truth is that this is not the full picture of how Web3 architecture is built. Because actually, there are more houses existing in the space at the same time. And you can think about each house as an individual blockchain, which lies in the foundation here in layer 1, and then different platforms and tools built on top of that blockchain. So let's assume now that the house on the left side is Bitcoin, and then the house on the right side is Ethereum. So what happens when, for example, I want to exchange my Bitcoin for ETH? They have to communicate in a specific way. And this is actually possible thanks to another layer that is kind of like a tunnel below the surface, below the houses. And this is the layer 0, also called protocol layer. This is where the nodes live, where the communication between the nodes and the different blockchains happens, and also where consensus mechanisms take place. So in the future videos, we will then go through each layer step by step to have a look what's inside and how it works.